Today, we're going to build a procedurally generated rectangle signed distance field in Unreal and Unity. Let's go. So we're in the middle of a series of videos on creating procedural shapes and patterns. And in the process, we're also building a library of subgraphs or material functions to help with that process. Last week, we created several new nodes in that library and then used them to create this lava lamp effect. I'll link the playlist for the series down in the description if you'd like to go back and catch up. Today, we're going to be creating a new signed distance field shape, a rectangle. We've already created an SDF circle shape that you can see here, so you may notice some similarities between these. So we're going to start out in Unity today, and we're going to build the rectangle signed distance field, and then we're going to switch over to Unreal and do the same thing there. So the first thing that I'm going to do is come down here to my project and find the SDFs folder, and I'm going to create a new shader graph subgraph here, and we're just going to call this rectangle. And then I'll open it up and we can get started. So the first thing that we need to do in our new subgraph is add a couple of parameters to the blackboard. We're going to have several more than this, but we're just going to start out with a vector2 parameter called UV to allow us to bring in our UV coordinates. And we're going to add a second vector2 parameter called size. And this is going to control the dimensions of our rectangle. So let's bring in our UV parameter here. And we're going to add a branch on input connection node, which will allow us to use default UVs if the UV port is not full. So I'm going to select my UV value over here in the blackboard. And then I'm going to open up my graph inspector and check this use custom binding box. And for the label, I'm going to call it UV0. So this is the binding that's going to be there if nothing is connected to the port. So I'm going to connect my UV input port to the input and the connected pin here. And then for the default UV coordinates, we're just going to bring in UV0 and connect that up to the not connected port on the branch on input connection. So this configuration of nodes here allows us to have default UV coordinates if nothing is connected to that UV port. Alright, so right now our UV coordinates are 0, 0 down here in the lower left corner. And we want to actually center that 0, 0 spot right in the middle. And so what we're going to do now is multiply by 2 and subtract 1. And that will shift the range of our UV coordinates from the 0 to 1 range to the negative 1 to 1 range in both axes. So here you can see now our 0, 0 point is right here in the middle. So now we have UV coordinates that are centered. The next thing that we need to do is add an absolute node because we want to make sure that we don't have values that are negative. So here you can see I've got these black areas where my values are going negative in the vertical and the horizontal axis. But once I add absolute, any negative numbers are turned positive. And so now I have a mirrored or a uniform set of UV coordinates that are the same across the central axis. And that's what I want to be able to do for my rectangle shape. All right, so right now I have an SDF of a rectangle that's infinitely small, but I want to be able to control the size of that rectangle. So the next thing that I'm going to do is add a subtract node. And I'm going to subtract the size parameters, or the size parameter here that we created in our blackboard. So I'm just going to drag this over to the subtract. And we want to set a default value to size. Before I just left it at 0. But I'm going to set the default to 0.5 and 0.5. And you can see that as I do that, now my box has opened up. And what I've got here is in the space outside of my rectangle shape, I have positive values, and now in the space inside of my rectangle shape, I've got negative values. So we're making good progress. We're actually almost there with the base SDF pattern. So let's go ahead and scoot these over. Now we just need to convert this. So this is a vector 2 value that has both u and v coordinates. And we need to add a couple of nodes to convert this to just a single float value where each of the pixels represents the distance away from the edge of that rectangle shape. That's why it's called a signed distance field. Okay, so in order to do this, I'm going to drag this out. And what we're going to do is find the maximum value between this input and 0. And now we're going to use the length node to measure how far from the 0, 0 point we are. So doing that, we get a length where every pixel's value represents how far we are from the edge of our signed distance field shape. Okay, so that's the first half that we're going to do. And now we're going to split out our x and y parameters here and find whichever is greater between x and y. So here, now we're getting a maximum of whichever is greater than 0, but I'm going to plug this in, and now we're finding whichever is greater between the x and the y. And then here, I'm going to use a minimum node to find out whichever is smaller than this or 0. So now I've got values that are in the negative here in the middle of my field. All right, and I'm just going to clean up these nodes a little bit. And now I'm going to add these two nodes together. And my result is our signed distance field. So here, outside of the rectangle, I have positive values that measure how far away from the edge of the rectangle we are. And then here on the inside of the rectangle, I have negative values that also indicate how far away from the edge we are. And just so that you can see those negative values just temporarily, I'm going to add a negate node here. And what this will show you is these are the values that are here inside the rectangle, but they're negative. And then these are the nice positive values that are outside the rectangle. All right, so I think we're ready to output these values as our SDF. So let's go ahead and do that. Here's my output node for my subgraph. And this just needs to be a float value. So I'm going to come down here and set this to float. And we're just going to call this output SDF. And I'm going to connect it up. And now we have a very simple signed distance field node here that creates our rectangle. So this is really basic. But I don't know if you remember when we created the circle, we added all kinds of other features that make this signed distance field node a lot more useful. And we're going to do that again today. So we've created our first step, but we actually have 5 steps in this process. The next step that we're going to do is we're going to take our signed distance field and actually make it into a solid rectangle shape. So if we don't want the SDF, we just want a rectangle, we're going to be able to use that output. So here I'm going to come over to my output again, and I'm going to add a new one, and we're just going to call this one fill. So this is going to be our filled rectangle. And let's go ahead and add the nodes here at the end that convert our signed distance field into a solid rectangle shape. So in order to do this, I need to add a couple of new parameters. I'm going to add a float parameter, and I'm going to call this one edge min. And another one, and I'm going to call this one edge max. And for our default values, I'm going to set edge min to 0. And for edge max, I'm going to set it to 0.01. And what these values here do is they control the width of the edge. Let's go ahead and do it, and I'll show you how it works. So what I need to do is add an inverse lerp node, and this is going to help me convert my signed distance field into a solid shape. So I'm going to drag in my edge min and edge max parameters, and I can just connect these up to the A and the B of my inverse lerp. And now you can see I've got a nice hard edge. It's not perfectly hard because I do have this default value of 0.01 here for my edge max, but it is a pretty sharp line. And the closer together I make the edge min and edge max values, the harder that line is going to be. Now, the inverse is also true. If I make my edge max value something like 0.3, you'll see that now I have a much fuzzier edge. So there's a softer edge here. And so I can use these parameters to control how hard or soft the edge of my fill shape is. Now, you might notice that my rectangle is white outside and black inside, and that's actually the opposite of what I want. So I'm just going to go ahead and add a 1 minus here, and then I'm going to add a saturate just to kind of complete this effect and make sure that my range is between 0 on the outside and 1 on the inside. And now I've got a completed fill for my sign distance field rectangle. So I'm just going to go ahead and wire the fill into my output node. Cool, all set. Let's go ahead and move on to step 3. And this is going to be to add a stroke or an outline. So instead of the solid fill shape of the rectangle, I'm just going to create an outline for the rectangle. And once again, in order to do this, I'm going to need to add a couple of more parameters in my blackboard. So first, I'm going to add a float parameter that's called stroke thickness. And we're going to default stroke thickness to 0.1. And then I'm going to add another one that's a Boolean. And this one is called stroke thickness relative. And this is going to determine whether or not the stroke thickness is relative to the scale of the rectangle. So as the rectangle scales up, do I want the stroke to get larger and larger as my rectangle is bigger, or do I want it to stay the same? So that's my stroke thickness relative, and we've set this to a Boolean, and we're going to go ahead and set the default value to true so that as my rectangle scales, that line will be relative to the scale. Okay, and then the last parameter that I need to add in my blackboard is going to be a drop-down parameter. And this one is called stroke dimension. And this is going to allow me to pick which of the dimensions of the rectangle, either width or height, we're going to be making our stroke relative to. So I'm going to come over here to my inspector, and for my stroke dimension, I'm going to set the options to width and height. And what this is going to allow me to do is add a drop down to my node so that I can pick either to make the stroke relative to the width dimension or to the height dimension. All right, so we've got all our parameters. Let's go ahead and build our stroke. So first I'm going to bring in my stroke dimension branch, and I have these two different inputs for width and height, and I'm going to make width a value of 0 and height a value of 1. And now what I can do is use this value as a branch. So I'm going to add a branch node here and connect this up to the predicate. So if stroke dimension is width, I'm going to have 0. And if it's height, I'm going to have 1. So that means if it's width, I'm going to have whatever's connected to false. And if it's height, I'm going to have whatever's connected to true. So now I can grab my size parameters here and add a split node. And I can connect my first size parameter to true and my second size parameter to false. And this is an easy way of choosing between whether I'm using the X, or the Y of size, and whatever's coming out of here is what has been selected by this stroke dimension dropdown that eventually will show up on this subgraph that I'm creating. All right, next I'm going to grab my stroke thickness and bring it in. And I'm going to multiply my result by our stroke thickness. And now I'm going to bring in my stroke thickness relative and branch based on that. So I'm going to connect stroke thickness relative to the predicate of the branch. And if it's true, we're going to connect this. But if it's false, we're just going to connect the pure stroke thickness. So here I've got stroke thickness, and here I've got stroke thickness multiplied by the dimension that I've selected. All right, now I'm going to take my size parameter, and I'm going to subtract the thickness value here, and I'm also going to add the thickness, and then I'm going to blend between the subtracted version of the thickness and the added version of the thickness, and that's going to be a blend of 0.5, and that's going to center my stroke right on the edge of the rectangle. And so these are the values that I've connected for my stroke. Now I just need to move them over a little bit, because instead of subtracting the size parameter that I've got here, I need to subtract the adjusted size parameter that I've calculated here. So let's go ahead and connect this up. And now we've taken the size of our stroke into account when determining the final size of the rectangle. Okay, the last thing that we need to do is actually take advantage of these new values that we've calculated here and create our outline, or our stroke value. So I'm going to pick our input here, and in the graph inspector, we're going to add a new value here, and we'll call this stroke, and I'm going to put it right there after fill. Now I'm going to take the signed distance field that we've calculated here, and I'm going to bring it down here and add an absolute node, because we've got negative values here in the middle, but we don't want those. We want actually our outline. So if we do our absolute, you can see we've got positive values out here, and now we've converted our inner negative values to positive. And now I just need to subtract the value that I calculated here for the outline. So I'm going to add a subtract node here, and we're going to subtract these outline or stroke values here. And now we've actually got an SDF for the stroke. And so to convert this SDF to the actual stroke itself, we're going to use the same technique that we used up here. And so I'm just going to go ahead and copy these nodes and paste them to here. And then instead of using our rectangle SDF, we're going to use our stroke SDF, and I'll connect this up to our inverse lerp. And there we go. So now you can see we've got a nice stroke output. We've got our edge min, our edge max, and we've got our nodes here that are converting our stroke SDF to stroke with a hard edge. So now I can just connect this value here up to our stroke. And we also want to add another output here called SDF stroke. And that's going to be this value that we calculated here. That's the signed distance field of our stroke. So I'm just going to connect this right up to our SDF stroke output. Okay, we're moving right along. This is great. We've got all of the outputs for our signed distance field. We've got our fill, we've got our stroke, our SDF, and our SDF stroke. But there are a couple more features that I want to add to make this even more useful. The first one is I want to add some controls to allow us to round out the corners. Right now, our shape just has hard corners, but if we want to make these corners smooth, we need to be able to round them out. And so let's go ahead and open our blackboard again. And we'll add a new input here called corner radii. And I'm going to make this a vector 4. And what this value is going to control is the radius of each of the corners of our rectangle. And so just by default, I'm going to make this value 0, 0, 0. So we're going to say by default, we're going to have a hard cornered rectangle. But I'll be able to control each of the corners of the rectangle independently with my X, Y, Z, and W values, so that I can make a rectangle with like 2 rounded corners and 2 sharp corners, for example, if I want to. Okay, so now that I have my parameter, in order to do this, I'm actually going to create a brand new subgraph that's called rounded corners. So I'm going to come over here to my helpers folder and right click and pick create shader graph, subgraph, and we're going to call this rounded corners. All right, so I'll open this one up and we're ready to create this subgraph. Now, the first thing that I want to do is copy this UV structure that I've created here so that I can bring in default UV coordinates. So I'm going to copy that and just paste it right in, and we'll set our label to UV0. So now I have default input UV coordinates. And just like we did in the rectangle, we're also going to multiply by 2 and subtract 1 to center our UVs. All right, and now let's go ahead and create those rounded corners. So I'm going to add a ceiling node, and what this node does is it rounds everything to the nearest integer. And then we're going to saturate the result of this. All right, so multiply by 2, subtract 1, ceiling, and then saturate the result. And now I'm going to split these values into the separate U and V. So here's my U and here's my V. All right, now I need a corner radius input. This is my vector 4 value that I created in the other one. So we're going to call this corner radii. By the way, radii is the plural of radius. So we're going to use that value there. And we'll bring that in and split it out into each of the individual 4 radius values. And we're going to take these first 2 and make them into a vector 2. So there's my vector 2 with my X and Y. And then I'll copy that and make another vector 2 with my Z and my W values. And now I'm going to blend between these vector 2's using a lerp. So here's my lerp node. I'm going to blend between this first vector 2 and this second vector 2. And my blend value is going to be my U coordinate here. And now I'm going to split these again. And then I'm going to blend between the red and the green, or the X and the Y again. And this time my blend value is going to be my V coordinate from down there. So there is my blend value. So here we're blending between X, Y, and ZW. And then here we're blending between whichever of the 2 we want based on the V. And this is going to give us our final output for our rounded corners. So I'm going to set my output to a float, and then my value is going to be called corners. All right, and then just a couple of things that I need to do to finish up this subgraph. First of all, I'm going to set my path here to procedural/helpers so that it will show up in the helpers folder when I want to access it in the add node menu. And then the other thing is I'm going to set my graph settings to preview 2D so that my preview will be 2-dimensional. All right, let's jump back into our rectangle graph, and we'll come in here to procedural, helpers, and there's the rounded corners node that I just created. So we'll add that to our graph. And we're going to go ahead and hook up our rounded corners input parameter here. And for our UV coordinates, we're going to hook these up right there. Okay, now we need to add in our rounded corners calculation, and we're going to do that right here. So I'll add the rounded corners there, and then connect this to our split and to our maximum. And then after we do our final SDF calculation here, we need to subtract our rounded corners value. So I'm going to subtract those values out right here. And now I can hook this up again. So I'm going to connect this to our lerp value, to our SDF output, and to our absolute down here. All right, so now that we've got our rounded corners in here, this subtract output value becomes our new SDF. All right, so let's go ahead and see what happens when we change our corner radii. If I set this to 0.5, aha, now you can see we've got a nice rounded corner in the lower left. And if I set all of these to different values, you can see that now we've got some kind of a lot of control over the shape of our rectangle here, because we can set each radius of each individual corner separately. So this is pretty cool. It's giving us a lot of flexibility in the way that we create our rectangle shape. And if I come up here to the actual shape output of the rectangle, you can see, just like we saw on the SDF, we've got these nice rounded corners, and we're able to set these values to however round or sharp we want the rectangle corners to be. So that's great. That is our rounded corners feature. We've just got one more feature to go, and we're going to stick it right in here. And this is our aspect ratio feature. We want to be able to control the aspect ratio of our rectangle. And right now, it's really easy because we have a square shape here and we have a square shape here. If I set my size parameter to something different, right now both the height and the width are set to 0.5, but I can set this to 0.3 and this to 0.8 if I want to change the ratio of my shape. But what happens if the aspect ratio of the actual shape that I'm applying this to changes? What happens if instead of being a square, this shape becomes really long or really tall? And I want to maintain the aspect ratio of my shape that's getting applied. Well, that's what we're going to work on now. So I'm going to come over here, and just like we created this rounded corners subgraph here, we need to create another one that's called aspect ratio. Before I create that subgraph though, I do need to create two new parameters in my blackboard. The first one is going to be called width height, and this one is going to be where I input the width and the height of the shape that I'm applying the shader to. And actually I created a float here. It needs to be a vector 2. So I'm going to come up here and pick vector 2, and we're going to call this width height. And I'm going to create another Boolean, and this one is going to be called keep aspect ratio. And this is going to allow me to control whether or not I want that aspect ratio to stay relative to the shape of the object that it's applied to, or to maintain its shape regardless of the width or the height of the object that it's applied to. All right, so now I need to create my aspect ratio subgraph. So again, I'm going to come down here to our procedural library helpers. I'm going to right click and pick create shader graph subgraph, and we're going to call this one aspect ratio, and we'll open it up and make this. So for my aspect ratio subgraph, there are actually a couple of different ways I can go about creating this, and I'm going to output several different methods of doing the aspect ratio. So here in my output, I'm going to set this to a vector 2, And this first one is going to be the ratio of the width to the height. This next one, again, it's going to be a vector 2, and it's going to be the horizontal aspect ratio. And the next one, again, a vector 2. And this one's going to be the vertical aspect ratio. So we're going to bring in our width and height values, and I'll add that parameter to our graph. And then I'm going to split these values out. So I'll have width in the first value here and height in the second value. And I'm going to divide width by height. And I'm also going to divide height by width. And now for each of these, I'm going to make it a vector 2. This one is going to have a value of 1 in the height there, and it's going to have the ratio in the width. So this is our horizontal aspect ratio. And then for our second value here, I'm going to create another vector 2. And this one is going to have this one is going to be the vertical ratio. And so I'm going to set 1 for the width, and then our height is going to be the ratio of the height divided by the width. So we'll set that one to our vertical aspect ratio. And then for the overall ratio, what I can do is take the maximum value of these two vector 2's that I've calculated, and that's going to give me the overall width-height ratio. So that's my aspect ratio, and I can use that to keep the aspect ratio consistent regardless of the width and the height of the value or of the object that I'm applying the shader to. So let's save this. Oh, and before I forget, we do need to set our path here to procedural helpers, and we're going to set our preview to 2D. Okay, now we're back in our rectangle, and if I open up our Create Node menu and open up Procedural and Helpers, now you can see we've got our nice new aspect ratio node there. And I can bring this in, and I need to connect up our width-height parameter. And now you can see I've got my 3 output values: ratio, horizontal, or vertical. And in this case, we're going to use the ratio value, but I want to branch here. So we've got this keep aspect ratio, and we're going to branch based on that. So I'm going to connect keep aspect ratio to the predicate, and I'm going to set the true value to this ratio that I've calculated. Now, if the branch value is false, we're just going to set these to 1 and 1. And now I can use this value to affect the size and shape of my rectangle. So if I come up here just after the subtract value and add a multiply, I can multiply the dimensions of my rectangle by my aspect ratio so that the dimensions stay consistent. If I have keep aspect ratio true, and I bring in the width and height value of the object that I'm applying this shape to, I can keep my shape square even if the object I'm applying it to is really wide by passing in the width and height values of that object. All right, cool. So now we have a full-featured rectangle SDF subgraph here. So let's go ahead and save it, and then I'll open up a sample shader and we'll take a look at what it can do really quickly. Before I forget, we do need to add the finishing touches here. For our rectangle, we're going to change the path to procedural SDFs, and we also need to change the graph settings so that our preview is 2D. All right, I opened up a new shader here just so that we can play around with our rectangle SDF that we just created. So I'll open our Create Node menu. I'll open the Procedural menu here, and you can see under SDFs, I now have both circle and rectangle. So let's add our rectangle here. And you can see here's our rectangle shape. And I can output our rectangle shape there. And now I've got a nice rectangle here. And we can set this to sprite as our preview. To see what the output of our rectangle SDF is. We can take a look at the stroke. So there's our outline. And here I can set the stroke thickness. So if I want the rectangle to have a really thin stroke, I can set it to 001 and get a nice thin stroke there. We can also output the SDF of our rectangle and the SDF of our stroke. So if the object that we're applying this to is something other than a square, we can set that object's width and height values here so that our rectangle will maintain its aspect ratio even when the object is scaling to different sizes. We can also set the corners. This is probably my favorite feature of this. We can set these corners individually. So there you can see I have 3 nice round corners and 1 sharp corner. So I can get some really interesting shapes. Let's see what happens if we set each of these to 0.5. So I can almost get something that's like a circle if I set these values to just the right amount. I can get kind of a circle shape, maybe 0.45. Yeah, so now I've made my rectangle into a circle by rounding the corners by just the right values. There, I've made the letter D by rounding these two and not rounding those two. So you can see there's a lot of versatility here. I can make larger rectangles, I can make different shapes. So this is great. We've got our rectangle SDF. Now, I don't have a lot of like showy graphics like I did last week with our lava lamp effect, but what I will tell you is that this rectangle SDF node is going to be the root of a lot of the effects that we create going forward. There are going to be a lot of things that we're going to be able to do with this. So it was important to make this one today so that we have it for the effects that we're going to create next week and the week after, that sort of thing. Okay, so that brings us to the end of what we're going to cover today, creating a cool looking rectangle sign distance field. I hope you enjoyed this one. Let's switch over to Unreal and make a rectangle sign distance field node there as well. All right, here we are in Unreal, and here is the lava lamp shader that we created last week. But today our focus is going to be on creating a sign distance field rectangle shape. So let's go ahead and jump right into that. I'm going to open my content drawer, and here is the library of material functions that we're creating. We have UVs and time and SDFs and helpers and gradients. Today we're going to add a new SDF material function, and right now all we have is a circle. So I'm just going to go ahead and right click, come down here to material and pick material function, and we're going to call this rectangle. And I'll go ahead and open it up and get started. The first thing that we need to do is bring in our UV coordinates. And so I'm going to add a function input, and instead of vector 3, I'm going to set it to vector 2. And we're going to label it UV. And I want to set up some defaults for this. So I'm going to bring in our texture coordinate node. And we'll just connect it up right there to the preview tab. And what this is going to do is make it so that the default texture coordinates are what get used when this input port on the material function is empty. And then we need to check this use preview value as default box. Okay, the next thing that I want to do is shift our UV coordinates so that the center is in the middle instead of in the corner. So I'm going to multiply by 2 and subtract 1. And then we're going to add an absolute node. And let's take a look at what this looks like. You can see that here, our texture coordinate center is there in the middle, but both in the vertical and horizontal axes, we're going into the negative. So by adding absolute, now I have kind of a more uniform, it's going from 1 to 0 to 1 horizontally, and also 1 to 0 to 1 vertically. All right, and so we might call this a sign distance field for an infinitely small rectangle. So the next thing that we need to do is bring in a size parameter. So I'm going to create a new input here. There's our function input. This one we're going to set it to scalar, and we're just going to call this size. Actually, I need it to be a vector 2 because it's going to have an x and a y. And I'm going to set these values to 0.5 and 0.5. And now we can use this size parameter to control the size of our rectangle. So in order to do that, all I have to do is come over here and add a subtract node and subtract this size value from these UV coordinates that I've been calculating. And now you can see I've got a nice box here in the middle. I've got a box in the red channel and I've got a box in the green channel, although we need to actually join these together so that we have one unified SDF as a float instead of two separate things. Okay, so in order to join this X and Y channel together, I'm going to come over here and add a split components node, and I'm going to find the maximum, whichever is greater between the X and the Y, and then I'm going to find the minimum between that and 0. All right, and then we're going to take our original value here from the subtract, and we're going to do another maximum between that and 0. And now I'm going to find the length. So there's my length node, and this is going to give me, there you can see, I've got a nice signed distance field. I'm going to take this value and this value and add them together. And now we've got our signed distance field. However, it looks like I'm getting an error here, and that's because if I mouse over this, it says it can't cast from float 2 to a float 3. So what's happening here is I have a float 2 coming out of this subtract, but this split components node expects a float 3. So instead of that, I'm going to use a mask component node instead, or a component mask rather. And I'm just going to set this one to the red channel, and I'm going to set this one to the green channel. And now we'll just replace our split components with that. There we go. So now we have our sign distance field. Perfect. So for our output, we can go ahead and wire this in, and instead of result, I'm going to call this SDF. So there's our sign distance field, and we can control the size of it with our size parameter over here. So we just zoom in here. You can see by default I've got it set to 0.5, but I can set this to like 0.8 and 0.1. And now you can see I've got a nice elongated rectangle shape instead of a square. So let's set these back to 0.5. And that's the first part of the tutorial. So we've got our sign distance field now, but we want to make this a little bit more useful. So we're going to add some more functions to it. So we have our SDF output here. We also want to go ahead and resolve this into a shape. And so in order to do that, I need to add a couple more input parameters. And so here's a function input. This one's going to be called edge min. And we'll keep that at 0 and set it to scalar. And then we're going to copy this one, and we'll set this to edge max. And we're going to set this to a value of 0.01. And now I can use these two input parameters to control the thickness, or the sharpness actually, of the edge of the shape that we're about to resolve. So in order to resolve this sign distance field into an actual shape, I'm going to use the inverse lerp node. There's our inverse lerp. And I can wire edge min into A and edge max into B. Oh, I forgot to check this preview box here. That's really important so that it'll use our default values. Then I'm going to wire our sign distance field into the value. And this will resolve our SDF, but it's inverted. So in order to fix that, I need to add a 1 minus and then a saturate. And now I've got my rectangle shape. So I can create another output. And we'll call this one fill, because it's our filled in rectangle. There we go. So we've got our SDF output and we've got our fill output. The next thing that we need to do is add our stroke, or like an outline. This is just a solid rectangle shape, but we may also want to create a shape that is just the outline of the rectangle. So it'll be black outside and black inside with just an outline. So I'll add a new output here. And we're going to call this one stroke. And in order to create our outline, we need to come back over here and add a little bit of functionality that controls how that outline works. So first of all, we need to add a couple of new parameters. The first one that I'm going to add is called stroke thickness. And I'm going to set it to a scalar value, and we'll set its default to 0.1. And check the use preview box. I want to make sure that I always check this use preview box. I wish it was just on by default. Okay, there is our stroke thickness. We also want to create another parameter, and we're going to call this one stroke dimension. And the way that this one is going to work is if it's a value of 1, we're going to use the width dimension. And if it's a value of 0, we're going to use the width dimension. And if it's a value of 1, we're going to use the height dimension. And that is going to determine which of those axes our stroke is relative to. It'll all be clearer in just a minute once I add the rest of these parameters. All right, the next one we're going to create is a Boolean, and we're going to call this one stroke thickness relative. We're going to set it to be a Boolean, and by default, we'll set it to be true. And I think that's all we need for our stroke for now. So let's add a couple of switch nodes in here. And what we're going to do is allow our parameters to control the thickness of our rectangle, but then also make it so that that thickness can be relative to the scale of the rectangle or not. And so the way that we're going to do that is we're going to take our size node, and I'm going to add a component mask here so we can split out the red and the green channel of the size. So there's the red. And this one's going to be the green. So we'll split those out, and we're going to switch between which axis or which dimension we're using based on this stroke input dimension value. So if this value is 1, or if this value is 0, we're going to use the width. And if the value is 1, we're going to use the height. And then we're going to multiply that dimension by our stroke thickness value. And then we're going to add another split here, or another switch rather. And we're going to use this input stroke thickness relative. So if this value is false, we're just going to use our straight up stroke thickness. But if this value is true, we're going to use the stroke thickness times the dimension that we selected. All right, so that is how we calculate the thickness value of our stroke. Perfect. All right, so now we want to center the stroke right on the edge of our rectangle shape. And so in order to do that, we're going to subtract our thickness from our size. And we're also going to add our thickness to our size. And this is basically just finding the middle of the stroke. And then we're going to take these two values and use a linear interpolate to blend between them with a value of 0.5. And that'll give us a stroke that's right on that edge where half of the stroke is on the outside and half of the stroke is on the inside. Okay, so I'm just going to move these nodes over a bit just to give us some more room. And then instead of subtracting our size value here, I'm going to subtract the result of all of this. And that will give us our new value there. Okay, I actually found two mistakes that I need to correct. The first one is that this switch node and this add are set up incorrectly. I need to actually connect this size input to the add and then connect the switch node to the B input of the add. All right, so I've got that set up. And then the other thing that I need to do is this input stroke node needs to be a Boolean. I had it set to a scalar before, and that wasn't working. So we need to set this to a static Boolean. And then I need to add some default values to these Booleans here. So I'm just going to set static Boolean values and connect these in. And we'll set them to default to true. There we go. And now I've got my preview render window back here because my shader is compiling again because of these corrections that I made. Okay, so now that we've calculated the dimensions of our stroke here, we need to actually come over here and use these values. So I'm going to come all the way over here to where I've computed the SDF, and I'm going to drag a node out here and add an absolute. So if you can see this preview here, we've got positive values on the outside and we've got negative values on the inside. So adding this absolute here is going to make positive values on both the outside and on the inside. And now I've got my stroke value here because you can see this black line on the edge of my rectangle. So now to control the width of that line, I just need to add a subtract node and come over here and grab this value that I've calculated for my line width. And now you can see I'm able to control that input that we created to control the thickness of my width. And this is actually the signed distance field of my line width. And that's one of the things that I want to output. So here's my output stroke. I'm going to go ahead and clone this. And we're going to call this new output here SDF stroke because it's the signed distance field of my outline. So I can just drag that in and connect up that signed distance field. Okay, now I want to actually compute the stroke or the outline. And that's pretty easy. I'm already computing the fill right here. And so I can just take these nodes and copy them. So I'm going to grab these three nodes and copy and paste them to right here. And now I'm going to connect up my edge min and my edge max to my inverse lerp. And I can connect up the signed distance field of my outline right there. And this is going to resolve the signed distance field of the outline into the actual outline shape. And now that we've done that, I can just pass that out to my stroke output. All right, very cool. I've got my fill output. I've got my SDF output. I've got my stroke output, and I've got the SDF of the stroke. So these are all of the outputs that we're going to use for our rectangle SDF node. We're making some great progress. This is fantastic. Okay, the next thing that we want to do is be able to control the rounded corners. Right now, the corners of our rectangle are sharp, and we want to control how rounded they are. And so, in order to do that, I need to create a new material function that rounds out those corners. And I've actually already done this. So I'm going to switch over to this tab here called Rounded Corners. And let's take a look at what this material function is doing. Let me just minimize our preview window here so we have more space to take a look at these nodes. And we'll zoom in on this. By the way, I created this Rounded Corners material function. If I open my content drawer and go to Helpers, you can see here I've got the Rounded Corners material function there in the Helpers folder. Alright, so let's take a look at what this is doing. I've brought in my UV coordinates, and I added a new material function input here called UV, and this is set to vector 2 input, and by default, it's just bringing in the texture coordinates. Then we multiply by 2 and subtract 1, which centers our UV coordinates right in the middle, instead of in the upper left like it normally is. And then we round up to the nearest whole number with a ceiling node, saturate our result, and then use the component mask nodes to split these so we have the red channel and the green channel separate. Alright, and then up here, I bring in another input, and I'm calling this one corner values. And you can see that this one is a vector 4 input. And what this is going to allow us to do is control the roundness or the radius of each of the 4 corners of the rectangle individually. So I have these 4 different values here. And right now they're defaulting to 0, 0, 0, 0. So none of the 4 corners are going to be rounded. But once I apply this material function, I'll be able to use these 4 input values to control the roundness of each of the 4 corners. Alright, I take that input and I split it into the red and green channels here, and then the blue and alpha channels there. And then I blend between those two using the red channel from down here. Alright, so I'm picking either the red and green or the blue and the alpha based on the red channel of this. Alright, and then I take the result of that and split it into the red channel and the green channel. And then I blend between those 2 channels using the green channel from down here. And then I output my result. So that is my material function that controls the rounded corners. Alright, let's go ahead and add this material function to our rectangle SDF node. So I'm going to bring up my content drawer, pick my helpers folder, and drag my rounded corners subgraph or material function into my graph here. And now I just need to hook it up. So what I'm going to do here is, starting with this subtract node here right in the middle of my graph, I'm going to drag out a wire, and we're going to add the result of our rounded corners to the process where we're building our SDF. Alright, so there's my rounded corners node. And I actually need to create a new input here. We're going to create a function input, and we're going to call this one corner radii. And we'll set up our default values. When I first create this corner radii input, we need to set it to be a vector 4. And notice here that this last value defaults to 1. We want to be careful of that and change it instead to 0 so that all 4 of our corners can default to the same value. And then I'm going to connect up that to the corner values here. And I'm also going to connect up our UV coordinates to the UV input on our material function. Okay, so now that we've added those rounded corner values to the UVs that we're creating here, I need to connect this add node and wire this into the rest of the graph. All right, so we've got our rounded corners added in there. And now the last thing that I need to do to get the rounded corners is come over here to where I've got this add node. And here I've added the rounded corner values. But here at this point, I need to subtract them out again. So I'm going to come to this add node here and add a subtract. And we're going to subtract away the rounded corner values here and then reconnect our results for all of these values. So wherever this add node was wired in, I'm just replacing these wires with wires coming from our subtract. All right, so this is going to give us the ability to control the roundness of the corners of our rectangle. So now if I come over here to this corner radii input, I can set each of these values. Like if I give it a value of 0.4, now you can see our upper left corner is nice and round. And I can do this for all of them. And we get nice rounded corners, and it's really cool. I can control these individually. So it'll allow me to make some really interesting shapes if I sharpen some corners and harden other corners. Like for example, if I set these two corners to be sharp, and then these two corners over here to be more round, I can create the letter D, for example. All right, so that's kind of neat. Now I can control the roundness of the corners. And the last thing that I want to be able to do is control the aspect ratio of my rectangle. Right now in the preview over here, the object that my rectangle is applied to is just a square. And so there's really no issue with the aspect ratio because it's always going to be square. But what happens if I apply this object to, if I apply this rectangle to an object that's stretched out really wide or scaled up really tall, and I want to keep the aspect ratio? Let's say I want this to always be a square, like regardless of the shape of the object that it's applied to. That's what we're going to take care of next. And so in order to be able to do that, I need to create a new material function node. And I've already done that. So let's take a look at this material function node called aspect ratio. So what I'm trying to do with this material function is determine the relationship between the width and the height of the object that I'm applying my rectangle to. So you can see, first of all, I've created this new material function input, and it's a vector 2, and I've set it to default to 1 and 1. So we're just kind of ignoring the aspect ratio to begin with because we just have these input values of 1 and 1. But I could wire in the actual width and height values of the object that my rectangle is applied to so that those values come in here and allow me to use them to control the aspect ratio of the rectangle. So I take the width and height values and split them out using the component mask into the red and green. So this one is the width and this one is the height. And the first thing that I do is I divide the width by the height. That's what this divide here is doing. And then I divide the height by the width. So I've gone both ways. I've divided red by green and I've divided green by red. For the first one, I come over here and I append 1. So this is going to give me the relationship between the width and the height in the first channel. And then in the second channel, it's just giving me a hard-coded value of 1. And I wire that value out here into this output that's called horizontal because it's my width divided by my height. And then I do the same thing here for the height divided by the width, except this time I append a 1 in the first channel and then put that divided value in the second channel. And I wire that one out to my output pin called vertical. And then to actually find the output, the ratio between the width and the height, I take these two values that I've calculated and I find the max between those two. So whichever one of those is greater, that becomes the width height ratio, and that's what I output there. All right, so my outputs are ratio, and then horizontal and vertical. And I can use these three outputs for different ways of controlling the aspect ratio. All right, we're going to switch back to our rectangle here, and I'm going to open up my content drawer, and there's the aspect ratio that I added, the material function, the aspect ratio, in my helpers folder. So I'm going to grab that and drag it into my graph, and you can see that I've got width and height inputs here, and then for the outputs I have ratio, horizontal, and vertical, just like we saw in the material function here. All right, so I need to wire this up, and this is going to be the last feature that we add. So I'm going to come up here in between my subtract node and my add node where I'm adding in my rounded corners. I'm just going to scoot this over, and we're going to multiply our coordinates by our aspect ratio. So I'm going to wire this out and create a multiply node and connect that up just like this. And then with our aspect ratio down here, we actually need to create another input. So I'm going to create a function input, and this is going to be a vector2, and we're going to call it width height. And again, we're going to default these values to 1, and I'm going to connect up my width height right there. And now I need to add one last input parameter. And this one's going to be a static Boolean. And we're going to call it keep aspect ratio. So if we want to apply our aspect ratio here, we'll set this Boolean to true. Otherwise, it's going to be false. And then I need to add a static switch node. And it's going to switch based on this Boolean value here. And if that Boolean value is true, we're going to use the ratio value coming out of here. But if it's false, we're just going to add a vector2 here. And I'm going to set these values to 1 and 1. So if it's false, we'll just use this hard-coded value of 1 and 1. All right, so there's our aspect ratio. And now we just need to connect this up to the multiply that we created there. And we're all set. Oh, one last thing here. When you add a static Boolean as an input value, you have to connect up a default static Boolean to the preview and check this use preview. All right, there we go. That is our rectangle signed distance field. We created the whole graph, and we've got our outputs, we've got our fill, we've got our signed distance field, we've got our stroke or our outline, and we've got the signed distance field of the outline. And we're able to round out the corners, and we're also able to control the aspect ratio so that our rectangle can maintain proper proportions regardless of the size or height or scale of the object that it's applied to, if we connect up those values with this width and height. Okay, let's go ahead and save this, and we'll switch over to a temporary shader that I created here so that we can take a look at the various features of our new rectangle signed distance field node that we've created. So here you see I've connected up the fill output. I could also connect up the stroke output to get just an outline, or I could output the SDF of the stroke, or the SDF itself. Now, I don't really like the order that these are set to, so let's go ahead and switch back to our rectangle and fix that. I'm going to come over here and we're going to set fill to be the first one, so it's 0. We're going to set stroke to be the second one, so it's set to 1. We're going to set SDF to be our third one, so we need to set it to 2. And then we're going to set SDF is going to be set to 2, and then the SDF stroke is going to be set to 3. There we go. All right, so now we've got fill stroke SDF and SDF stroke. Perfect. Now let's take a look at a couple of these settings. If we want to control the corners, we can connect up a vector 4 value. And this is kind of an awkward interface because it's a color, but you can see as I change these values, we can round out the corners of our rectangle and give each corner its own unique value. There we go. We can also control the size of our rectangle. So if I connect this up to our size, you know, we've got a size of 0, so we've got no rectangle. But I could set this to 8 and 2, and now we've got a long shaped object here. That's pretty cool. So there's all these inputs that we can set, and it looks like the last couple of values that I added aren't quite in the right order, and I want to fix that as well. So I want my UV value here to be first. I've got this keep aspect ratio here, and so let's fix the order of our inputs. We're going to come back here to our rectangle SDF. We added a couple of inputs down here. Here's our corner radii input, and we actually want it to be a sort priority of 4. So we'll set that. And then these last ones down here are width and height, and our keep aspect ratio. We're going to set this one to be a sort priority of 8, and our width and height to be a sort priority of 9. So if we save this and come back to our temp shader here again, now we've got them in a better order. All right, so the last thing that I want to say is this rectangle SDF node that we've created is really versatile, and I didn't create a lot of cool effects to show off with it today, but what I will say is that in the coming weeks, we're going to be using this rectangle node as the basis for a lot of the new effects that we're going to be creating. This is kind of going to be our foundation. So be sure that you create this node and that you're ready to come back in the next couple of weeks to use this over and over for all kinds of different things. All right, that does it for today's video. I hope you enjoyed this one and that you have a great week, and come back for some great shapes and patterns in the coming weeks as well. All right, have a good one, everybody.